Welcome to this video on solving a system of equations by elimination, also called addition. There are three ways to solve a system of equations: graphically, using substitution, or using elimination, which is also sometimes called addition. Recall that when we learned to solve equations graphically, we found three possibilities. There might be no solution. For example, in this case, you can see we have parallel lines. Anytime you have two parallel lines, they never meet or they meet at infinity, so we would say they have no solution. We could also have infinite solutions. Remember that infinite solutions happen when we have two lines that end up being the exact same line. They have every point on their line in common, so there's an infinite number of points they have in common. So we would say that there are infinite solutions. The third option is that we have exactly one solution, where two lines meet at exactly one point, and this is some ordered pair x comma y. So those are the three outcomes that are possible when we solve graphically. Those same three outcomes are also possible when we solve using substitution, as you saw in the substitution video. So when we solve graphically and we have no solution, that means we have parallel lines. Algebraically, we would obtain a mathematically false statement in step 2, such as 0 equals -4. In both cases, our final answer would be no solution. If there is exactly one solution, graphically, we would be able to see where the two lines intersect on the graph. Algebraically, we would be able to find a value for x and a value for y and write it as an ordered pair. Lastly, if there are infinitely many solutions, graphically, we end up graphing the exact same line twice. Algebraically, we end up with a mathematically true statement in step 2, such as 0 equals 0. In either case, we would write infinite solutions as our final answer. To eliminate something means to get rid of it. When we use elimination, we eliminate one of the variables, so we have an equation with just one variable. We can then solve this equation for that variable, and then proceed just as we did in the process of substitution. Elimination is sometimes called addition because we can sometimes, but not always, add the two equations together in order to eliminate one variable. A more accurate way of describing it is that we can add or subtract any scalar multiple of either equation to the other. Since we don't always add, sometimes we subtract, many textbooks use the term elimination rather than addition. Let me show you what I mean. In this first example, let's try adding these two equations together. So we have 2x plus 1x. That's 3x. Then we have y plus -y. That's 0y. Then we have 3 plus 0. That's 3. Well, we don't really need to write 0y, so we could just write 3x equals 3. So simply by adding the two equations together, we have successfully eliminated our y variable. Of course, that's not the end. I just wanted to demonstrate what we mean by elimination. Let's look at this other example. Let's try adding these two equations together. 5x plus 3x is equal to 8x. 1y plus 4y is equal to 5y. 7 plus 11 is equal to 18. Notice that by just adding these two equations, we did not succeed in eliminating either x or y. Both variables are still in the equation when we sum them. So again, in some instances, it's sufficient to just add the two equations together. In other problems, we're going to have to do some other steps. So please keep that in mind. Here are the 4 steps that we're going to be using to solve when we use elimination. First, we choose a variable to be eliminated, and then we eliminate it. Then we solve for the other variable. We plug that value into one of the original equations, and then we use the equation that we didn't use in step 3 to check your work. Notice that step 3 and 4 are exactly the same in elimination and in substitution. Also, let's talk about this asterisk. When I say choose a variable to be eliminated, the reason we have to put an asterisk here is that in order for the variable terms to be eliminated, they have to have the same coefficients and opposite signs. That's why in the first set of equations that you saw on the previous slide, they canceled out because they had the same coefficients and opposite signs. In the second pair of equations, they didn't have the same coefficients and opposite signs, and so of course they didn't cancel out. Notice that if we don't have terms in two equations such that they have the same coefficients and opposite signs, we'll have to create them ourselves. Don't worry about this because we are going to do a few problems first before we get to that step. Let's just focus on the 4 main steps here. Let's start with example 1. Remember, the first step asks us to choose a variable to be eliminated and eliminate it. We're looking for 2 variable terms that have the same coefficient and opposite signs. Do you see any terms like that? What about 2y and negative 2y? They're both 2, and one is positive and one is negative. So these already exist. So here is step 1. Step 1 is that simply by adding these 2 equations together, 1x plus 1x equals 2y, 2y plus negative 2y is 0y, 5 plus negative 3 is positive 2. So again, just by doing that, I have eliminated one variable. So that is step 1. So now on to step 2. I have eliminated y, which means I can solve this equation for x. All I have to do is divide both sides by 2, and I find that x equals 1. Now, remember, I need to find both x and y. So in step 3, I can use either equation to find my other variable, which is y. Let's use this equation right here. 1x plus 2y equals 5. Remember, we just found that x is equal to 1, so we'll put that in place of x. So I have 1 plus 2y equals 5. If I subtract 1 from both sides, I get 2y equals 4. And then if I divide both sides by 2, I find that y equals 2. Okay, so let's go back to our steps. We found that x is equal to 1 and y equals 2. So it looks like we've done step 1, step 2, and step 3. But don't forget, the most important step is to check our work. As you can see, we've done a lot of steps, we've done a lot of work, and the probability that we made a mistake is pretty high. So when we check our work, remember we have to use the equation we didn't use in step 3. So what equation did we use in step 3? We used 1x plus 2y equals 5. That means we have to use the other equation, which is 1x minus 2y equals negative 3, in order to check our work. So we said that x is equal to 1, and we said that y is equal to 2. So we have 1 times 1 minus 2 times 2 equals negative 3. So 1 minus 4 equals negative 3. So negative 3 equals negative 3. That checks out. That is true. Okay? Remember, when you get a true statement in step 4, it does not mean you have infinite solutions. When you get a true statement in step 4, it means that you have the correct answer. So our final answer here is the ordered pair 1, 2. Let's do another example. Remember, we have to choose a variable to be eliminated and eliminate it. Already, we have a negative 3x in one equation and a positive 3x in the other. Therefore, by simply adding these 2 equations together, negative 3x plus 3x, then we can get rid of our x terms. Then we have 2y plus 7y, which is 9y, and 2 plus 7, which is 9. So all of this is step 1. On to step 2. Now we need to solve for y. We've eliminated x, so we solve for y. And we get y equals 1. So this is step 2. Now we have y equals 1. We can use either of these 2 equations to find x. I'll use the first equation. Again, y is equal to 1, so I'll put 1 in place of y and fill out the rest of the equation around that. Remember, it's always a good idea to draw that vertical line through your equal sign so you don't lose track of the 2 sides of your equation. I'm going to subtract 2 from both sides. Oops, I guess I don't really need that. There we go. I'm going to subtract 2 from both sides of the equation. You get negative 3x is equal to 0. Divide both sides by negative 3, and I get x is equal to 0. So again, we have y equals 1, x equals 0, but we haven't done the most important step of all, which of course is to check our work. Okay, remember when we check our work, we can't use any old equation. I just used this equation right here. I just used that equation in step 3. I therefore have to use the other equation, which is 3x plus 7y equals 7, if I want to check my work. Okay, so we have x is equal to 0, we have y equals 1, and let's see what happens there. So I have 3 times 0 plus 7 times 1 equals 7, 0 plus 7 equals 7, so of course 7 equals 7. Okay, so I do have exactly one solution. My x is 0 and my y is 1. Okay, remember, just because I got some number equal to itself doesn't mean I have infinite solutions, because why? Because it happened in step 4 when I was checking my work. It didn't happen in step 2 when I was trying to find x and y. All right, let's do another example. This problem says 3x minus 4y equals 8 and 5x plus 4y equals negative 24. So our first step is to choose a variable to be eliminated and eliminate it. Notice that our variable terms that contain y already have the same coefficient and opposite signs. That means that simply by adding these two equations together, I can eliminate one of my variables. So 3x plus 5x is 8x, negative 4y plus 4y is 0y, or just 0, and 8 plus negative 24 is negative 16. So therefore, I have successfully accomplished step 1 of this process. Now I have to solve for x. So I will do this simply by dividing both sides by 8, and I find out that x is equal to negative 2. Now, I like to, in each of these videos, deliberately make a mistake so that you can see what happens when we get to step 4 and we have the wrong answer, and then we can see how to check it. So, as you can see, the answer should clearly be negative 2. But I'm going to do positive 2. I'm going to just pretend like maybe I forgot that negative sign, I forgot to bring that down, maybe I did my addition wrong. So let's see what happens when we intentionally make a mistake. Let's see what happens when we get to step 4. And then we'll go back and we'll fix our work. Okay? So we're on to step 3. We have to plug the value x equals 2 into one of these two equations. Okay? It doesn't really matter which equation that we choose. So just out of convenience, I'll pick the first equation. 3x minus 4y is equal to 8. Okay? So again, I'm going to put 2 in place of x. And then evaluate this. So 3 times 2 is 6. So we have 6 minus 4y equals 8. Again, I'm solving for y, trying to isolate that variable. So I'll subtract 6 from both sides, bring down my negative 4y. So I have negative 4y is equal to 8 minus 6. 8 minus 6 is 2. Then we would have to divide both sides by negative 2. So we would get y is equal to negative 1/2. Okay? So if I were correct, which we know I'm not because I deliberately planted a mistake in here, but if I were correct, I would have the answer 2 and negative 1/2. Okay, so hopefully this is illustrating for you why it's so vastly important to check your work. So let's look at step 4. Okay, so again, in step 4, we have to use the equation we did not use yet in step 3. So in step 3, we used 3x minus 4 equals 8. So I can't use that again in step 4. I have to use the other equation, which is 5x plus 4y equals negative 24. So let's see what happens when we put 2 in place of x and negative 1/2 in place of y. So I'm just bringing down the rest of the equation around these values. That's an equal sign. 5 times 2 is 10. 4 times negative 1/2 is negative 2. So we end up with something that looks like 8 equals negative 24. And this is clearly not true. So again, remember, if you would end up with something like this in step 2, that means there's no solution. But when you end up with that, an untrue statement in step 4 when you're checking your work, that means that you have made an error somewhere in your math and you have to go back and fix it and check your work. Okay? So we already know that I deliberately made an error right here. and that this should be negative 2 instead of positive 2. So what that would mean is, let's pretend this was a homework question or something that I was doing. I would have to go back to step 3, and I would have to put a negative 2 in x, and I'd have to find y all over again. So I would get negative 6 minus 4y equals 8. Then I would need to add 6 to both sides. So I get negative 4y equals 14. Then I would divide both sides by negative 4, and I end up with y is equal to negative 7 halves. Okay, so now I have two new different answers. Okay, so I need to still do step 4 all over again. I need to check these answers because, what if I made another mistake? It happens. All right, so let me erase this work here. Okay, so 5x plus 4y equals negative, equals negative 24. Okay, so this time I'm going to put negative 2 in place of x, and I'm going to put negative 7 halves in place of y. Okay, so let's see. 5 times negative 2 is negative 10. 4 times negative 7 halves is negative 14. Okay, so we end up with a statement that says negative 24 equals negative 24. So that's true, it checks out. Okay, so now I can be confident that I have the right solutions. So my final answer is that there is one solution at negative 2, negative 7 halves. And I'd also like to take a moment to point out that just because you have a fraction, a non-integer answer for y, that doesn't necessarily mean you did something wrong. Okay, so you're not always going to get whole numbers or integers for x and y.